The possibility of life on Mars has piqued curiosity of scientists for ages. NASA's Perseverance rover, which has been hunting for signs of ancient life on the red planet, has stumbled upon a strange object.
Come on, let's admit it, the idea of moving to Mars has a certain allure. Who hasn't fantasized about watching two moons rise on the horizon while sipping coffee in a pressurized dome? Too bad the reality is tremendously more complicated and, to be frank, far less glamorous. We're talking about living in a place that would make the Sahara Desert look like a five-star tropical resort. This isn't an exaggeration, trust me, I've spent years studying Martian colonization projects and have reached a conclusion that might disappoint Star Trek fans: we are not moving to Mars. Not in the next century at least. And probably that's for the best, for all the reasons I'll explain in this superb video. A planet designed to kill you. Let's start with the most uncomfortable truth: Mars wants to kill you. Not personally, of course, but the effect remains the same. The atmosphere is so thin that your saliva would boil on your tongue if you tried to breathe outside. The atmospheric pressure is less than 1% of Earth's, practically like being in the vacuum of space. Cosmic radiation would bombard you constantly, exponentially increasing cancer risk. And as if that weren't enough, it's ridiculously cold, with average temperatures of -63 degrees Fahrenheit, -52 degrees Celsius, dropping to -126 degrees Fahrenheit, -88 degrees Celsius during polar nights. But hey, one advantage is that you'd weigh only 1/3 of what you'd weigh on Earth, of course, with the consequence that your muscles and bones would atrophy in just a few months. To understand how hostile the Martian environment is, consider a simple mental experiment. Imagine being on Mars's surface without a spacesuit. Here's what would happen chronologically. Within 15 seconds, you'd lose consciousness from lack of oxygen. Simultaneously, the water in your tissues would begin boiling due to the nearly non-existent pressure, causing rapid body swelling. Your lungs would instantly collapse. Your blood would literally start boiling in your veins, and death would liberate you from all problems in about 60 to 90 seconds. Not exactly a walk in the park, right? And these are just the most obvious problems. Then there are global dust storms that can last months, completely obscuring the sky and reducing visibility to just a few meters. Mars dust is particularly insidious, composed of microscopic sharp particles containing toxic perchlorates. This annoying slurry would end up infiltrating machinery, space suits, and inevitably our lungs. Moreover, a recent University of Michigan study demonstrated that Martian dust is potentially carcinogenic and could cause severe lung inflammation, similar to silicosis, a disease that afflicts miners on Earth. Yet despite everything, we continue to hear grand promises from politicians, builders, and scientists, visionary or not. In 2016, when Musk presented his ambitious plan to colonize Mars by the 50s of this century, he spoke of transporting 1 million people to the red planet in 2025. That promise appears increasingly distant. SpaceX's Starship, a crucial element of this plan, has faced numerous delays and test failures. The first complete orbital flight occurred only in 2023, well beyond initial timelines, and subsequent tests have shown significant reliability issues. Similarly, NASA's Artemis program, intended to return humans to the Moon as a springboard for Mars, has undergone continuous postponements, with the Artemis II mission pushed to 2025 and Artemis III to 2027, far from the original timeline. And this is for the Moon, which is 1,000 times closer than Mars. The illusion of a planet B. After all, the history of space exploration is peppered with overly optimistic predictions. Remember when in 1969, after the first moon landing, NASA predicted permanent lunar bases by the 80s and human missions to Mars by 2000? Or when in 2004, President Bush announced the Constellation program that was supposed to return us to the Moon by 2020. These programs were cancelled or drastically scaled back. The truth is that space is incredibly difficult, expensive, and dangerous, and technical challenges are consistently underestimated. To put it in perspective, the average distance between Earth and Mars is about 140 million miles, 225 million kilometers. With current technology, a trip to Mars would take between 6 and 9 months. During this period, astronauts would be confined to a tight space, exposed to dangerous levels of cosmic radiation, and completely isolated from any immediate help from Earth. In case of a medical or technical emergency, there would be no possibility of evacuation or quick resupply. Communications would experience delays of 4 to 24 minutes depending on the relative positions of the two planets. This means no real-time video calls with loved ones, no Netflix, no immediate support from Earth in case of emergency. But why are we so obsessed with the idea of establishing colonies on Mars? It's not easy to understand. There must be something psychologically attractive about having a planet B if we mess up Earth. But it's a dangerous illusion that risks distracting us from the real problems we need to address here. Think about it for a moment. If we can build completely sealed and self-sufficient habitats on Mars, why don't we do it first in the Gobi Desert or Antarctica? It would be infinitely easier and more economical. Yet we don't do it. Aerospace engineering pioneer Louis Friedman, co-founder of the Planetary Society, compares this unfounded enthusiasm to unrealized visions proposed during the 40s and 50s of the last century. Back then, magazine covers like Popular Mechanics and Popular Science showed colonies under the oceans and in Antarctica. Friedman stated, "The feeling was that humans would find a way to occupy every nook and cranny of the planet, no matter how challenging or inhospitable." But this simply didn't happen. We make occasional visits to Antarctica and even have some bases there, but that's it. Antarctica has breathable air, normal pressure, normal radiation levels, and we still don't live there permanently. There are some scientific bases, but nothing close to a colony. And underwater is even worse. Despite being full of resources and relatively easy to reach, we don't have underwater cities. The Biosphere 2 experiment conducted in Arizona in the 90s is particularly instructive. 8 people lived for 2 years in a closed, self-sufficient ecosystem designed to simulate space colony conditions. Despite being on Earth, with all the conveniences of normal atmospheric pressure, Earth's gravity, and radiation shielding, the experiment encountered enormous difficulties. Oxygen levels dropped dangerously. Crops didn't produce enough food. Pollinating insects died. And interpersonal conflicts grew to the point of dividing the group into hostile factions. Okay, but if we can't maintain a closed ecosystem on Earth, how can we hope to do it on Mars? Famous astrobiologist David Grinspoon recently observed that the idea that we can simply move to Mars if we destroy Earth is scientifically illiterate. Earth, even severely damaged by climate change or other catastrophes, would remain infinitely more habitable than Mars. And he's absolutely right. The worst imaginable scenario on Earth, whether catastrophic climate change, nuclear war, or global pandemic, would still produce a planet more habitable than Mars. The air would remain breathable, atmospheric pressure suitable for human life, water abundant, and gravity ideal for our bodies. The limits of technology. But perhaps you're thinking, technology will solve all these problems. Our engineers will know what to do. Well, okay. Our engineers are good. But there are physical limits that not even human genius can easily overcome. Take the radiation issue. On Mars, you'd be exposed to about 50 times more radiation than in New York. The latest 2024 research on mice exposed to similar radiation levels shows significant neurological damage. You might live underground or in shielded bases, but you can't stay enclosed forever. Sooner or later, you'll have to go out, and each time will be a risk. Reproduction challenges. And then there's the reproduction question. Do you really want to raise children on Mars? The most recent studies are far from encouraging. Experiments on mammals in Earth's orbit between 2022 and 2024 showed abnormal embryonic development and high mortality rates in microgravity conditions. Dr. Vasharajan from King's College in London, a specialist in space gynecology, yes, that specialization exists, recently stated that based on our current data, there are significant reasons to believe that human pregnancy on Mars might be impossible without extremely invasive medical interventions. Specifically, Martian gravity, which is about 38% of Earth's, could interfere with crucial embryonic development processes that depend on correctly perceiving the gravitational vector. The fetal cardiovascular system, nervous system, and skeletal development could be compromised in ways we don't fully understand yet. Everyday survival. Another monumental challenge, everyday survival. Limited access to fundamental resources like food and water could impose additional constraints on a colony's ability to grow and thrive. Establishing a stable resource base for long-term habitation is conceivable, but it will be extremely challenging. Colonists will want to live close to water and ice, but for that, they'll have to move far enough north where conditions on the surface become increasingly harsh. Winters are bitterly cold and there's less sunlight. The colonists will also need a stable food supply and must find a way to shield their crops from radiation. Mars' regolith is toxic, containing dangerous perchlorate chemicals, so it must be avoided for cultivation.